Welcome to class today. In today's class, we are going to talk about the theory of logarithm. Now, when you talk about the theory of logarithm, what do we need to understand about the theory of logarithm? And as you can see what we have here, we are having these short notes to describe and explain what theory of logarithm is all about. Now, we have been taught indices. Now, if you are new to this channel, when we talk about indices is talking about multiplying a number or a variable by itself continuously. And in that case, when you are multiplying a particular number or a variable by itself, be it, let's say you're having x, you are having x multiplied by x multiplied by x. In this case, this is what we refer to as index. That means x raised to power 3. This is the shortcut of expressing a multiple of number by itself is what we refer to as indices. Now, when you have an index number like this, then we can also describe this index number with the concept of logarithm. So when you talk about the theory of logarithm, you need to understand some basic principle about indices. Now, how can you express your indices in a logarithm form, and how can you express your logarithm form in an index form? In this case, when you talk about the logarithm of number to base 10, which refers to as common logarithm, we are not considering other bases. Peradventure, we are not considering base 2, base 3, base 4, and other bases. But in theory of logarithm, we want to look at the logarithm of a number in other bases other than base 10. And the logarithm of any number n to any base a, the logarithm of any number n, logarithm of any number n to any base a, as you can see there, is a power or the index x to which the base must be raised to be equal to the number. That means this equals to x. Now, what this statement was saying is that the logarithm of any number n to base a is the power or the index to which the base must be raised to equal to the number. That means this is the base. The base must be raised to this power, to this number, which is equal to the number, the logarithm of the number you are given. I explain again. The logarithm of any number n, this is the number n, to any base a, the base can be any other variable, base a, is the power or index to which the base, this base, must be raised, that is raised to power x to be equal to what? N. So that means when you are writing a number in index form, this is what we refer to as index form. And this is what we refer to as logarithm form. So you can write a number or express a number in logarithm form and the same number also in index form. As we can see, if you are conversant with the use of calculator, we are going to see that if you press the calculator, for instance, you can pause this video, take your calculator and press log 1. When you press log 1 on your calculator, log 1 is to base 10, and the answer will give you 0. Meaning that, let's look at it in what we just said. The logarithm of any number or of any number n to any base a is what? Is the power or the index to which the base, that means this base must be raised. That means here now is going to be 10 raised to power 0 to be equals to 1. That is how we are having it here. If 1 is equals to 10 raised to power 0, then log 1 base 10 is equals to 0. The same thing, if you are having log 10 base 10, log 10 base 10 will give you 1. If you press log 10 in your calculator, you get the answer 1. That means you are having here now 10 raised to power 1 is equals to what? 10. Then we have it the other way around. Log 100 is equals to, that means 100 is equals to 10 raised to power 2. Then that is log 100 base 10 is equals to 2. Then that's why I have, if you are having n equals to a raised to power x, then log n base a is equals to x. This explains the theory of logarithm. Now, having said that, there are some other things we need to consider under the theory of logarithm, and that is what we refer to as the laws of logarithm. So when you talk about the laws of logarithm, what are we going to talk about under the laws of logarithm? What are the laws of logarithm that we want to consider here? We are going to consider the law of logarithm based on what we have explained in the theory of logarithm here. That means if you are having log n to base a plus log m to base a, that's the first one. Number one, log n to base a plus log m to base a. Ensure that you are having the same base. This equals to log m times n to base a. That means you multiply the number, or you can even put the n as you have it here, n and m. You are still having the same thing. Log n plus log n, having the same base, is going to be log n times n base a. Now the same thing goes with the second. When you're having log m base a minus log n base a, since you're having the same base, now remember that this is log m and this is log n to base a and to base a. This is equals to log m over n to base a. Now, number three, if you're having log m raised to power p to base a. Now, the number is having a power. This is going to be p log m to base a. Now, number four, if you're having log m to base m. Now, the number and the base are equal. This is equals to 1. When you're having the logarithm, that means the log of a number equals to the base, the answer is equals to 1. Now, we are still moving forward. Number 5, if you're having log 1 to any base, log 1 to any base, this is equals to 0. Log 1 to any base, this is equals to 0. We also have some other ones. Number 6, that means when you're having, this is change of base, log m to base n, log m to base n. I can change the base of this, and this is going to be log m base a over log n base a. These are talking about the laws of logarithm. Now, we are still going to have the next one. Let's still have another set, number 7. In this case, we are having log m to base n to be equals to 1 over log n to base n. Now, can you look at what happens there? You can see here you're having log m to base n is equals to 1 over, then when you take the reciprocal of it, it's going to be n to base n. That is when you are talking about inverse of logarithm. This is change of base of logarithm, and here you are having inverse of logarithm. Now, this explains the laws of logarithm, and we are going to see how we can apply each of these laws of logarithm to answer questions, and also the application of it in solving logarithm equations. Now, for what happens there, you can see here you're having log m to base n is equals to 1 over, then when you take the reciprocal of it, it's going to be n to base n. That is